where it's supposed to be. All right, so we're gonna go ahead and get started. I think everything is where it should be. All right, so today we're gonna take a look at the next couple of sections in chapter 2, section 2.1 and 2.2. 2.1 is algebra's common graphs, and 2.2 is the transformations of graphs. So the first thing we're going to do is look at algebra's common graphs. And we're also going to use a calculator to graph these things as well. I want to bring that up. All right, I'm just going to sit there to the side for now. All right, so up until this point, we've talked about a linear equation. And for a linear equation, that's in the form y is equal to x. So as I mentioned in the last class, this is just the general form. So we talked about slope-intercept form, which was y is equal to mx plus b. So in this simplified linear equation, y is equal to x, the slope, right, which is the coefficient of x, is understood to be 1. And the y-intercept is where the line or the graph crosses through the y-axis, and that's also considered to be 0. Right? So if you were to graph a linear equation, it would look something like this. Okay. We talked about the special types, the vertical, the horizontal, and if you read the graph from left to right, in this case it goes up, so it's positive. If you read the graph from left to right and it goes down or descends, it's negative. Okay, but this is just the most general form of a linear equation. The next kind of equation we're going to take a look at is a quadratic equation, and this is in the form y is equal to x squared. And when you graph a quadratic equation, it forms a U-shaped graph called a parabola. All right, so I'm actually just going to graph that on the calculator. All right, so if I go to y equals, I'm going to put in x to the second power, and I'm going to hit zoom 6. Right, and we have the parabola, which is a U-shaped graph. So that's the most basic shape of a parabola. The next graph we're going to take a look at is a cubic equation. And a cubic equation is written as y is equal to x cubed. And if you were to graph a cubic equation, it will form an S-shaped graph. Right, so I'm going to graph that in the graphing calculator as well. Right, so I don't actually have a quick cube power, so I'm going to just use the caret. Right, so that caret is the exponent raised to the third power, and if we graph, notice we have an S-shaped graph. Now, in the next section, we actually talk about the transformations of graphs. And what a transformation is we can take these graphs, we can move them to the left, we can move them to the right, we can move them up, down, we can also reflect across an axis. Okay, and those would be considered the transformations of graphs. All right, the next graph we're going to take a look at is the absolute value. Right. And the absolute value graph is written in the form y is equal to the absolute value of x. And if you were to graph an absolute value equation, it produces a V-shaped graph. Now, if you're graphing the absolute value on your calculator, the absolute value function itself is sort of hidden. So I'm going to go to y equals. I'm going to clear out that equation. I'm going to go into math. Under math, I'm going to scroll over to number. And under number, you see ABS, which is short for absolute value. I'm going to hit enter. So one thing about the calculator, it doesn't actually give us the absolute value bars. We actually get parentheses which alludes to the absolute value bars. So I'm going to put in the variable x. I'm going to close off the parenthesis, which is the absolute value, and I'm going to graph. All right, so notice that it produces a V-shaped graph. So the next graph is the square root graph. So the square root graph is written in the form y is equal to the square root of x. And its general shape looks something like this.
I have a question. Thing for a virtual tour. I know there's this virtual tour going on campus right now. We're trying to set up videos and stuff like that. We were just wondering if, like, if we set this up here, if you mind us capturing a few minutes every like a minute or so of your lecture with the students and stuff. I didn't know if you might.
That's fine. That's fine.
Okay. The guy who's actually shooting it will be here in a second and set it up.
Okay. Okay.
Just let it shoot for a second so we can get you on tour.
Okay.
Teaching,
Okay.
showing skills off.
All right. All right. So this is the square root graph, and if we put that into our calculator. All right, so I'm going to go into y equals and clear that out. So this is the square root of x. And if we graph, all right, so just notice that basic shape. All right, so these are the 5 basic graphs that we're going to deal with. Okay, as far as continuous graphs, so let me explain the difference between a continuous function and a discontinuous function. A continuous function is a function such that I'm just going to write this on the side right here. You can retrace the graph without removing the pencil from the paper. Right, so for each one of these graphs, you can put your pencil on the graph. You can trace the entire graph without removing the pencil from the paper. for a discontinuous function or a discontinuous graph, in order to trace the entire graph, you have to trace your graph for a portion, you have to remove your pencil from the paper, and then you have to put it back on to retrace the graph. Okay, so the next two functions we're going to take a look at are discontinuous functions. All right, so we have what's called the reciprocal function. And let's see. All right, we have what's called the rational function, which is y is equal to 1 over x. All right, so if we were to graph the rational function, right, the rational function looks something like this. And this is considered to be a discontinuous graph, which means that if we were to trace this graph, we can trace the graph for a portion of the graph, and then we have to take the pencil off. We'd have to put the pencil back on to retrace the graph. All right, so I'm going to graph that in the calculator. All right, so I'm going to go to y equals, I'm going to put in 1 divided by x. All right, and we have the graph for the rational function. Okay. So here again, this is a discontinuous function. The next function we're going to look at is the reciprocal function. And the reciprocal function is written in the form y is equal to 1 over x squared. And the reciprocal function looks something like this. So notice here again, these two functions are discontinuous functions. So I kind of forego the writing out that long drawn out definition. But for a discontinuous function, it's a function in which you can trace a portion of the graph and you have to remove the pencil from the paper to retrace the graph. All right, I'm going to put that into the calculator. So 1 divided by x squared. All right, so just notice the basic shape of the graph. All right, so here are the basic, well, some of algebra's common graphs. Okay, well, the ones that we're going to deal with in our section. So the next thing we're going to look at are the transformations of graphs. So what do I mean by transformations of graphs? So we're going to be able to look at a graph, and based upon its basic shape, right, one of the 5, 6 different shapes we just looked at, excuse me, one of the 7 different shapes we looked at, We'll be able to take a graph, we'll be able to visually look at it, and we will be able to write out the function of that particular graph. Okay, and these are based on what are called the transformations of graphs. So first off, we have what's called the model form, y is equal to f of x. F of x can be any one of the 7 functions previously mentioned. Right, so f of x could be quadratic function, f of x could be the reciprocal function, f of x could be the square root function, right? If we were to take f of x, right, which is our function, and if we were to add some constant, so plus c is a constant, this is what's called a vertical shift c units. Okay. Also, just to be clear on this, this is a vertical shift up c units. And we're actually going to take a look at a function, okay, as well as some shifts. Y equal to f of x minus c is a vertical shift down c units. Right, so in order to shift a function up, you would simply take that function, you would just add some constant number, and that would shift the graph up. If you wanted to vertically shift the graph down, you would subtract some number from your function. All right, so let's take a look at an example. All right, so we're going to kind of look at y is equal to x squared, right, the parabola. So I'm going to just draw a rough sketch of an x and a y axis. And y equal to x squared should look something like that, right? So let's just say we wanted to take this x squared graph and we're going to shift it up 3 units. So let's just say this is our graph, right? And we've shifted it up 3 units. So that's a shift up 3 units. Okay. So how would you write out the equation for that graph? Right. So well, if we kind of go back to our transformations, it says that I'm gonna just put some numbers used. For number 1, a vertical shift up c units, we would take the function and we would add some constant to it. So we will write this out as y is equal to x squared plus 3. All right, so that takes that x squared graph and then pushes it up 3 units. So I'm actually just going to verify that with the calculator. All right, so I'm going to go to y equals. I'm going to just clear out the functions that I have. For y sub 1, I'm going to put in x squared. And I'm going to graph. Right, so notice that's the basic graph. I'm going to go back to y equals. And for y sub 2, I'm going to put in x squared plus 3. And then I'm going to scroll to the far left. Right, and I'm going to hit enter 1 time. Right, so once I go to the far left and I hit enter 1 time, it's simply going to graph the second curve as a thicker line just so I can distinguish between the 2 lines. So you may or may not have seen that before. So now if I hit graph, right, so notice that my thicker line, and I'm going to try to blow this up, which is y sub 2, and it is x squared plus 3. Right, notice it shifted the graph up 3 units. Right, so if you wanted to shift any one of the previous graphs we talked about up, you would just simply add a constant. All right, so on the flip side, let's take the graph x squared and let's shift it down 3 units. So what would be the equation for this graph? Well, since we're simply shifting it down 3 units, we would take our function f of x, which is x squared, and we would subtract 3. Right, so to shift something up or down, to shift it up, you just add the number of units you want it shifted up. To shift it down, you would simply subtract. All right, so just to see that on the calculator, I'm going to go to y sub 2, and I'm going to change the plus to a minus, and I'm going to regraph. So notice that is a vertical shift down 3 units. All right, so that is the transformation of up or down. All right, so now we're going to talk about moving into the left and to the right. So I'm going to write out these model forms, f of x minus c, and this is a horizontal shift to the right c units. And then we have f of x plus c. And this is a horizontal shift to the left c units. All right. So now notice how these model forms are written. All right, so let's see how they operate as far as the functions are concerned. All right, so let's just say we wanted to take the parabola and we wanted to shift to the left c units, or 3 units. So this is a shift left 3 units. Okay. All right, so how do we write out the equation? So now this is where your intuition and the math don't really go together. So if you think about a horizontal number line, right? Whenever you move to the left, you're actually moving in a negative direction, right? And whenever you move to the right, you're actually moving in a positive direction. Okay, but for our left and right transformations, the positive and negative are reversed. All right, so now since I'm shifting this to the left 3 units, I'm going to write this out as y is equal to x plus 3 quantity squared. So just 2 things I want you to notice. First off is that if you look at the top, when we simply just add 3 to our function, that's just the up or down shift. So if we look at the shift up 3 units, we would take whatever value for x, we would square it, and then we would add 3. But if we take a look at the shift to the left, we would take the value for x, we would add 3, and then we would square it. All right, so notice that this first plus 3 is simply attached to the outside of our function. But notice for the shift left, the plus 3 is actually attached inside the function. So let's take a look at the calculator just to verify. All right, so I'm going to go to y sub 2. I'm going to clear that out, and I'm going to put a set of parentheses. I'm going to put in x plus 3 quantity squared. Right, I'm going to change my thin line to a thick line. Right, and I'm going to regraph, and notice that is a shift to the left 3 units. So normally when you think about going to the left, that's actually in a negative direction. All right, but notice I'm not putting -3 on the inside, I'm putting positive. All right. So that's one thing you need to be careful of whenever you move to the left or to the right. All right, so now on the flip side, we're going to take the parabola and we're going to move it to the right 3 units. So this is a shift to the right 3 units. All right, so how do we write out the equation? Okay, well, going back to our model forms, a shift to the right C units is minus a constant, right, inside of the function. So I'm going to write this out as y is equal to the quantity x minus 3 squared. Okay, so just to verify that with the calculator, I'm going to go back to y equals. I'm going to change that plus 3 to a minus 3. And notice we have a shift to the right C units. All right, so any questions about how to take a function, shift it up, shift it down, shift it to the left and to the right? All right, now we can do this with all, well, we're not really going to use linear. I just kind of threw linear in. Okay, but we can do that with all of these functions. Now, the last transformation we're going to talk about is reflect across the x-axis. So we have y is equal to negative f of x. And this is to reflect across the x-axis, excuse me. Right, and this is how you would reflect a function across the x-axis. Right, so what does that mean? So let's take a look at the absolute value once again. All right, so to reflect across the x-axis, right? So how would we write this particular function? Okay. Well, the model form just simply says we would take whatever our function is, right, f of x, and we would simply multiply by a negative. So we can write out the equation for this graph as y is equal to negative x squared. All right. So we're just going to verify that with the calculator. So I'm going to go to y sub 2, clear that out. I'm going to put in negative x squared. Now, one thing you want to keep in mind, you want to make sure that you use the negative and not the minus. Okay, if you use a minus, you will get an error when you graph. So now I'm going to graph. And notice we have reflected the graph across the x-axis. All right, so now we're going to take our model forms, right? How to shift up, down, left, right, how to reflect across the x-axis. And we're going to write the equations for some graphs. All right, so here again, I'm going to do hand sketches. I'm not going back and forth because I can cut off the recording. All right, so here is the first sketch. So the directions say write the equation. So 1, 2, 3, 4, 5. I'm just going to go out to 5 in all directions. And we have this graph. So just to make sure we have the same. All right. So I'm just putting 3 at the bottom and then 2 just so we know where this parabola, where it bends. All right, so based upon what we know about parabolas, this would be the graph of y is equal to some kind of x squared, right? So I know I'm dealing just based on the shape, I know it's a parabola. Now we have to determine the transformations or the shifts that's been placed on this parabola, right? Well, I know that this parabola has moved 3 places to the right, and it's also been shifted up 2 units. All right, so remember that for the basic quadratic, right, it's centered at the origin. All right, so that means this graph has been shifted over 1, 2, 3 places to the right, and it's also been shifted up 2 units. So how would we write out the equation? All right, well, let's do it in some steps. So first off, we have to identify the model. So what I mean by the model is the models are one of the equations we just talked about. It either has to be a quadratic, cubic, absolute value, square root, rational function, or reciprocal. So based on the shape, this is a parabola. Y is equal to x squared. All right, so I'm going to start with that. Y is equal to x squared. All right. So now let's look at the up or the down shift. All right, so identify the vertical shift. Right. So now vertical shift can either be up or down. right? So if this graph starts here, right, in its most basic form, from its original position, it was shifted up 2 units, right? So how would I account for shifting the graph up 2 units? Right. Well, I would simply take my model form x squared and I would add 2, right? Because that would shift it up 2 units. So y is equal to x squared plus 2 because we moved it up 2 units. So once we moved it up 2 units, now let's identify the horizontal shift. Right, so horizontal can either go left or it can go right. So once we shifted it up 2 units, then we shifted it over 3 places to the right. So how can I lift that out? Write that out. Okay, so 3 units to the right. Okay, so how would I account for moving the parabola 3 units to the right? Well, if I go back to the model, to the transformations, right, shifting it 3 units to the right, I would actually subtract 3 from within my function. So I'm going to write that out as y is equal to the quantity x minus 3 quantity squared plus 2. And this is my final equation. Right, now, you don't necessarily have to go in this order. I mean, you should find the model form first, and then you could identify the horizontal shift and then identify the vertical shift. Right? There is no right or wrong or any particular order. Okay, but I generally like to find the model form. I like to find any vertical shifts, okay, because that's just a matter of either adding or subtracting, from your function. And then I'd identify the horizontal shift, and then I would identify any reflections across an axis. All right. So is everybody okay with that one? All right, so let's look at a couple more. So here is another one. So I'm going to go out to 5 in all directions. 1, 2, 3, 4, 5. 1, 2, 3, 4. And 1, 2, 3, 4, 5. Right. 2, 3, 4, 5. So this is negative 5. 1, 2. All right, so we're given this graph, and we're asked to write the equation. All right, so we're going to follow the steps from the last example. The first thing we want to do is identify the model. Right, so based on the models that we looked at earlier, this is a V-shaped graph. So since this is a V-shaped graph, we're going to identify this as the absolute value. Right, so the first thing I'm going to do is just identify it as a absolute value, V-shaped graph, and the model form is y is equal to the absolute value of x. Right? So the V-shaped graph, okay, that's where it starts, right? And the V shape is pointed up. Okay, the second thing we're going to do is identify the vertical shift right? All right, so we're going to identify the vertical shift. So this thing was shifted down 3 units. Right, so it would then look something like this. So how will we account for shifting that absolute value down 3 units? All right, well, we would simply subtract 3 from our function. So now we're going to identify the horizontal shift. Right, so we shifted it down 3. Now we're going to shift it to the left 5 units. Right. So notice once we shift it to the left 5 units, it's still a V shape that's pointed up. So how will we account for shifting the absolute value function to the left? If we go back to the transformations, if you were to shift it to the left, you would add 5 within the absolute value function. So we have y is equal to the absolute value of x plus 5 minus 3. So that shifts it down 3 units and 5 units to the left. But notice it's reflected over, right? It's kind of reflected over x. So to reflect across x, right, we multiply the absolute value by negative. So I'm going to write this out as y is equal to negative times the absolute value of x plus 5 minus 3. So we're actually going to graph this one just to make sure. All right, so we shifted the absolute value down 3, we shifted it to the left 5 units, and we reflected it across the x-axis. All right, so let's graph that one. So I'm going to go to y equals, and I'm just going to clear both of those out. And for y sub 1, I'm just going to put in negative, right? You want to use a negative, not the minus. Okay. And remember that absolute value is within math. I'm going to scroll over to number. And we have x plus 5. Make sure to close off your absolute value, minus 3. All right. And if you graph, all right, notice that it's similar to the hand-drawn graph. All right. And there is one more I want to take a look at. All right. Any questions? Is everybody okay with what's going on? I'm going to go out to 5. 1, 2, 3, 4, 5. 1, 2. I'm trying to get this right. 1, 2, 3, 4. 1, 2, 3. Okay, let's take a look at the rational, the reciprocal function. So I'll give you a second just to sketch that out, and we're going to do the exact same thing. All right, so the first thing we have to do is identify the function, right? So based on our functions, this would be identify the function, the reciprocal function. So y is equal to 1 over x squared, right? So that basic graph will look something like this. Okay, the second thing we're going to do is identify the vertical shift. All right, where that reciprocal function, it was shifted down 3 units. So down 3 units. So if we shift it down 3 units, right? right? It would appear to look something like this. Right. So in order to shift anything down 3 units, we would simply just take the function, subtract 3. So we can write that as y is equal to 1 over x squared minus 3, right? Now we're going to identify the horizontal shift, excuse me. All right, so we identified it as the reciprocal function. We moved it down 3 units, so we just simply subtracted 3 from our reciprocal function. And now we're moving it 4 places to the right. So since we're moving 4 units to the right, we want to subtract 4 from within our function, right? So this is how we're going to write that out. I'm going to write this out as y is equal to 1 divided by x minus 4 quantity squared minus 3. Right, so notice that minus 4 goes within our function and it's attached to x. So to verify that, I'm going to graph. Right, so I'm just clear out y sub 1. I'm going to put in 1 divided by, I'm going to use the begin parenthesis, x minus 4. Okay, close off my parentheses, squared minus 3. And I'm going to graph. And I'm going to blow that up a little bit. If I can. All right, and we have our graph. All right, the rational function shifted down 3 units and 4 units to the right. All right, so at this time, I'm going to stop the recording.